Welcome to the Aerospace Advantage podcast, brought to you by PenFed. I'm your host, Heather Penney. Here on the Aerospace Advantage, we speak with leaders in the DoD, industry, and other subject matter experts to explore the intersection of strategy, operational concepts, technology, and policy when it comes to air and space power. As we look to future warfighting capabilities, autonomy and artificial intelligence are growing in prominence when it comes to defining those aircraft, mission systems, weapons, and even battle management and other command and control functions. The underlying assumption is that autonomy and AI are necessary to achieve the speed and quality of decision and action against a peer adversary like China. But are we building the right foundations for the autonomy and the AI? Can the AI industry actually deliver what the warfighters need and want? We must ensure that as we write the algorithms for the autonomy and then train them, that we're doing so in a way that these systems can seamlessly coordinate with their human teammates, adjust quickly to the changing threat environment against a dynamic and adaptive adversary, adhere to commander's intent, and effectively expose internal decision-making processes for legal and reliability analysis. Spoiler alert, it all comes down to curating the data that includes warfighter context, along with the objective data normally associated with those missions. And what does that mean? So, this week, we're going to explore the topic of the missing data needed for advanced autonomy and tactical AI, covering 3 themes that we'll explore in depth. So with that, I'm honored to introduce 2 key experts in this area, Bobaloo Rickard and Mark Drifter Valentine. So Bobaloo is a former weapons school instructor and operational test pilot in both the F-16 and the F-22 community, with over 2 decades of human training research experience. Bobaloo, thanks so much.
Lucky, it's great to be here with the Mitchell Institute. I'm grateful for your leadership and participation with us. I want to cover 3 big topics today with you. First, a disciplined, repeatable, CSE-based process where we empower the warfighters directly to derive the complex requirements we're going to need for advanced autonomy and AI. Secondly, a methodology that we've developed over 10 years to gather, store, collate, and amass contextualized data across the joint force. And then probably most importantly, how that contextualized data provided to the AI industry will lift all boats. It'll allow them to actually make the complex AI that we're all dreaming about.
And you've been involved with this for so long, because since you founded your company, RCG, in 2004, you've been doing this kind of mission engineering, SME support, and advanced software development for over 2 decades. That's pretty phenomenal.
Yeah, it's been a long journey, and it's lucky that, no pun intended, it's a great.
I get that all the time.
It's great that our foundations all come to a head right now when the industry needs it most.
Thank you. And I'm super excited to have Mark Drifter Valentine back. So as you know, Drifter and I go way back, and he really has been a leader in the F-16 community, and he's one of the biggest brains that I know. So Drifter, he's got a high level of credibility, and that spans from everywhere from military affairs and policy with respect to the use of complex autonomy and AI to everything that he's done in the civilian world, the commercial world, being on the leadership teams of technology companies like Microsoft Defense, Scale AI, and now Skydio. And Drifter's even testified before Congress on issues related to AI and drone warfare. Thanks so much for joining us, Drifter.
Yeah, thanks, Lucky. It's great to be back. Too kind of an intro for me. I've probably killed many of those brain cells. But I tell you what, I've been involved in this space now for well over a decade, and it's time to actually make something happen and turn the talk into action. So anything I can do to make that happen, I'm willing to do. And I've been working with Bobaloo, talking with him on his process. And I think this is the direction we got to go. So look forward to the discussion.
I couldn't agree more. All right, so gentlemen, as we jump into this conversation, let's set the stage, because our regular listeners are pretty familiar with collaborative combat aircraft, CCA, and the other discussions that are surrounding autonomy and artificial intelligence. But let's baseline it for today. As I mentioned in the intro, everyone has usually had their most experience with ChatGPT and other large language models, and those are impressive for their ability to present what appears like human-like thought. And they've also experienced self-driving cars like Waymo and Tesla, which are becoming more and more common. So what's the problem? And why shouldn't defense leaders have a similar expectations of performance for military systems?
Well, that's a great intro. I think the biggest difference right off the bat is In the military, we have different moral and legal obligations for the things that we produce. For example, in the self-driving car industry, if something happens, it's not a national security incident. If you could imagine future AI put in a combat environment and something goes wrong, and the chairman or the secretary has to get on CNN and explain it, that's a big deal. So it's a mistake to translate what we see as a pretty open sky in civilian AI and narrow down the focus, I think, through more specific requirements for the military applications of that AI.
Yeah, Lucky, I'll jump in here as well. The short answer, I think, to the question is military leaders should absolutely expect AI outcomes that meet or actually exceed what's going on in the commercial industry. As Bobaloo said, I mean, you've got lives on the line, right? So the stakes are way higher. But military operations often happen in more severe operating conditions. So you're going to have capability that exceeds what we're seeing right now in the civilian world. But here's the thing, it's going to take longer. And that's what I think people have gotten frustrated with. And it's going to take longer because the civilian and commercial operators really have been working with data for a lot longer time. They have more of the data. They've built pipelines from everything from data ingestion to collection, aggregation, annotation, model deployment, model verification, validation, and then deployment and refinement. So that is built into and baked into their workflows already. And oh, by the way, the tactical environment that we're talking about is a little more complex than some of the things that we're seeing in the civilian sector. Mm-hmm. So, whereas, I understand the perception stack in a lot of the self-driving cars is extremely complex because you're trying to determine if someone's going to cross the street or not. If you think they are, you hit the brakes. If you think they're not, you keep going, right? It demands a high level of precision because you can't be wrong, but that is fundamentally different than thinking about a complex environment where I see this tactic in front of me. I've got these weather conditions, this EM environment. Now what do I do? And so in a lot of ways, we always need to go back to the fact that computers learn a lot like humans, okay? And much like as baby fighter pilots, we went through a training pipeline that started with advanced handling characteristics. So you understood how the airplane operated at high angle of attack, slow speeds, tight turns, etc. Then you moved up the chain and you did BFM or 1v1 dogfighting, where you took your AHC capabilities and started maneuvering against another airplane, and so on and so on and so on, until you got to full-on ACT or mission employment type things where you're working air-ground tactics with other people in a robust training environment. So if you think about that pipeline, AI is kind of the same way, right? You've got three different levels of AI. You got narrow AI, which I liken to like part task training in the F-16, like the advanced handling characteristics, where you would train an AI to do something very, very specific, like one thing. And then you've got more generalized AI, where you start to string all that together, and then you end up in like super intelligent AI, which is Terminator type stuff, right? And that's likely never going to happen. So understanding all these complexities and developing all these narrow AIs, stitching them together to do complex behavior is just going to take longer because there are more permutations.
Yeah, I mean, and as you mentioned, commercial AI, they've been doing and collecting this data for decades, right? They've been working on this for quite some time. And so when you look at those large language models, they can scrape the entire internet and they can look at libraries and libraries of books to be able to develop those mathematical algorithms that simply predict the next word. Or if you take a look at the self-driving cars, you have Tesla has all of their cars feeding data back into their model all the time. And there's a fairly, limited scenario of potential outcomes, whether that's the deer jumping across the road or icy streets and weather conditions. It's somewhat predictable, but in combat, there's that fog and friction of war. And Drifter, as you said, it is incredibly complex. And then we'll get those surprises. You have an adversary that is not accidentally crossing the street, but actively trying to deny your sensors, confuse your operations, induce errors, and reveal surprises in war reserve modes that you don't know about and cannot predict. I think that makes it incredibly harder.
100%.
And those self-driving car companies bring out a great example that we're going to talk about, which is they trained their algorithms with artificial data for very many years.
Artificial data is synthesized data, right? It's stuff that they make up.
Right. And not until they went out into the real world and had actual cars in the real environment did they get a training that allowed them to actually be put into use and safe. And the corollary in the military realm is we can't just rely on synthetic data, contrived data, or in the simulator world, computer-generated forces to run scenarios and train AI. And in the forum that we were in, Lucky, I brought this up. And I asked a room full of very experienced warfighters, I said, raise your hand if you would trust the best simulators and the computer-generated forces that you've used in the military to represent you tactically in real combat. And nobody raised their hands. So if the government does not supply a better data set to the AI industry, that's what we're going to be left with.
Yeah, because if we're using synthetic data, we run the risk of permutating and building error upon error upon error. And so that would result in unviable behaviors and decisions by these algorithms. And so, as you know, that's not something that we can do. We can't afford to do that in combat.
And they were never designed to be tactical.
Yeah.
Right. They were designed to do one thing and model a certain simulator, a radar or a capability.
Yeah. Drifter?
Yeah. Like synthetic data can be helpful in certain situations, right? To supplement data deficits that you might have. But the issue is, and no one really wants to talk about this, is that no one really knows exactly what a computer is looking at within a data set, the parameters that it's looking at to learn something, right? Now, we can make proxies. If there's a photo, is it looking at the shape, is it looking at the tones, is it looking at the size, the texture? Really, no one can tell you. It just learns, right? And so if you're making a synthetic data set, how do you know what to present to the computer, right? And well, if it's looking at size, shape, color, okay, you do a bunch of different size, shapes, and colors, but what's your resolution on your camera? How is it impacted by shadowing and lighting? And there's some cool tools that will help people build synthetic data and data sets, but it's almost impossible to consider all those variables. And then when I think about applying it to complex aerial tactics, it makes my head explode. It cannot be the primary way.
Yeah. So Drifter, you had mentioned okay, computers are going to learn a lot like we learned as baby fighter pilots, and we went through pilot training and we did the advanced handling characters and so forth. But once you become a fighter pilot, you do the debrief, right? That is how we continue to learn and hone and refine not just our skills and our execution, but our judgment, how we're thinking, how we're making decisions, how we're then going to manage the broader team. So let's talk about that entire mission cycle, not just the debrief though, right? Because all of this is going to matter when it comes to the automation.
That's a key point. So our culture right now is plan the mission, go out, do it, recreate it in the debrief one step at a time, get some lessons learned, take a couple notes, and then it's over. There's never been in any military a pragmatic attempt to give a leave behind for the next people to learn from. We brute force it. Our human brains tend to derive context through repetition. But we could improve that training tremendously if we would get all of the context out across the entire mission set as opposed to just talking about the debrief. If AI didn't even exist as a term, it would be a key enabler or an asymmetric advantage for the military to increase our learning potential by doing this. The catalyst for this now and why it's so important to address is because we need that data set from our human learning to train the future AI. If we don't give them that data set to the previous conversation, they'll make up their own data and the results will not be what we expect.
Yeah, we don't want to have those kinds of surprises when it really matters.
Correct. And it's really cool because we learned with very little contextual data. When we start learning from ourselves, the results will be nearly immediate. Drifter said, it'll take a while to get a set robust enough to start actually using that to train future AI, but we'll get a good benefit from our human training right away.
Mm. Yeah, so I totally get that. We need to avoid the Terminator Skynet problem to be able to confidently use kind of that middle ground that Drifter, mentioned, the artificial general intelligence, but we're still not there yet. So software companies aren't really getting the requirements they need to build the kind of autonomous systems that our warfighters will require or, frankly, trust.
That's very true. There's documents like DoD Instruction 3000.09, America's AI Action Plan, that talk ethereally about, hey, if we're going to do AI, let's do it good, right? Mm-hmm. But there, to date, is not enough specificity in what the government expects out of the AI that the industry makes. And that means they can have a wide interpretation. And if left on that same course, they're going to make AI. Nobody can sit here and say that AI companies can't make AI for the military. They will. But without a data set that has warfighter trusted context, that AI will be opaque, unexplainable, inflexible, and ultimately not trusted by the warfighters. We want to intercept that now, raise that issue, and start to build that data set before it's too late.
Because if you have good data, you're going to have better outcomes with the artificial intelligence. But if you don't, then you get unpredictable behaviors and decisions and outcomes. Before we go on, I hear you say contextualized data. We need context. We need context. Can you define that? What does that mean? And how does that change the quality of the data?
Yeah, that's a great question. So I'll give you an actual example.
Okay.
There is a giant repository of F-35 data at Nellis Air Force Base. Every jet, every mission.
Oh, it's a vacuum.
It is a huge building full of data. So pretend you're a weapons school student in the current weapons school class, and the instructor says, go down there, watch the missions from last class in this phase, and don't make any of the mistakes that they did. Could you do it? Could you learn from that data? And the answer is no. It doesn't have anything but objective data. You can see this was good, this was bad, but you don't know why. You don't know what the commander's intent was. You don't know what the briefing was, the tactics they planned to do, if that was even valid. Mm-hmm. You don't know if they did the plan. All you know is something happened. So contextualized data would be all of the stuff that's in our human brains. Somebody is watching the mission tactics plan go down. They're evaluating that in real time. That is critical data. What did the commander or the syllabus demand out of the mission? Would we do it again if we had that same situation? That subjective input from the warfighters themselves is the national asset that's never been gathered from any mission because there's no requirement for us to have a leave behind for the next people.
Yeah, we have the leave behind for ourselves because you always take your book into the debrief and you write down everything that you learned. But other than human to human, you're either sitting in the bar or you're instructing or you're sharing with your buds about what happened, why it happened, was it good, was it bad, what you'd do differently. We have those books for us, but we don't capture that in a robust way for data to be able to feed the machines.
Yeah, every weapons school student has shown up not knowing what the previous class learned. Every red flag group, every massive exercise, including recent examples of Midnight Hammer and the Venezuela thing, there was an immense amount of lessons learned, good, bad, and very few people, if any, are going to be able to take advantage of that if they weren't there to see it themselves. That is a national asset that dies every day, and that is the critical piece to enabling AI companies to produce better AI for us in the future.
Yeah, look, I want to jump in here real quick because I don't think you need to be a fighter pilot to understand this concept of the importance of contextualized data. Mm-hmm. So let's go back to our foundational thesis that computers generally learn in a similar fashion to humans. In other words, through associations. Mm-hmm. So we associate this picture with that sound equals this concept. And if you show enough associations, even a baby will eventually learn that, hey, that face with that sound and that smell equals mom. Okay. And that's how a baby learns. And that's generally how a computer learns. And same thing with a computer. You give it enough pictures of cats and dogs, it'll learn that this picture is a cat and that one is not, so on and so forth. So this process is called deep learning in the computer science world. And to make it more accurate, humans have to participate in that loop through what's called data annotations or labeling. Okay, for some things, that's it. But if you get to like super complex things like, all right, what's the right tactic to executing against this formation at this time of day, in this EM environment with my current fuel state, very few people have the subject matter expertise to answer that question. And oh, by the way, the answers to those questions aren't generally a yes, no, 0, 1 type answer. Okay, there's really only better and there's worse. So that makes it even more complicated. So you have to know who is saying what is good and what is bad. And much like a human conversation, my guess is you're probably more willing to accept tactical instruction from a patchware and a WIC debrief than a wingman lieutenant with 100 hours in the bar on a Friday night. That's what context is, and adding context to the data. And the computer needs it just like we as humans need it. And capturing it, though, that's the hard part. And my spoiler alert here is you've got to integrate that data capture in the warfighter's existing workflows. Because if you make it an additional step, you add any more friction to that process, it will be used and it will therefore fail.
Yeah, or worse, it'll be used, but used poorly, sloppily, and quickly. And so the quality of the data goes down, and therefore the quality of the algorithm goes down. Okay, so talk to me about this process. Cognitive systems engineering, right?
Yes, this is a key part of it that kind of transcends beyond the AI topic per se. If you involve warfighters directly in developing and evolving requirements, by definition, they'll be accepted on the backside. Never once have any of us been involved in developing a requirement for something that we got as warfighters.
Oh, yeah. It showed up and you're like, okay, cool.
Flipping that paradigm empowers the warfighters to be on the input side of the requirement. It speeds up the process and it speeds up the acceptance and uses of that. So apply that now to the data contextualization. If we sit with warfighters, to your point earlier about, hey, it has to be very unobtrusive for them to be data annotators and do their mission, we'll work out that best way with them and then put that back in front of them. We've seen this, we've practiced it in an earlier program, and on day one, people go, wait a minute, you want me to do this? And on day 5, when they realize that by putting their expertise inside the mission and then using that to learn for the next mission, they buy in immediately and they want more of it. So there's a great benefit by involving the warfighters directly that we can't even begin to underestimate. It's going to be a revolution in our learning process. And just like Drifter said earlier, even ants need context to learn. And there's no context in the data we have in the military right now. As soon as we add context, it's going to lift all boats. So obviously what we want to do is across the entire mission cycle, gather not just what happened, but why, directly from the warfighters. So developing a UI with their participation is key to doing that. Another very important input variable is the demographic data of the warfighters themselves. Contrast a brand new lieutenant with a black border patch from weapons school. If we have an understanding on the input side of the experience level of the warfighter and how that evolves, we can apply a reinforcement value scientifically.
You basically
to the
weight
inputs.
The value of
Exactly.
the data.
That's very important. And that's never been done. And that's part of our methodology.
Yeah, Wingman Snuffy is not going to matter as much as Drifter Valentine.
Exactly. Now, another key part of that is we have to teach warfighters how to be data annotators. Drifter hired thousands of data annotators off the street and told them to look at pictures and video when he was at Scale AI. And your average human could do that without any training. But put the warfighters in a complex joint all-domain environment, there's nobody that can do that except the warfighters themselves. And if they don't speak in a common language of annotation and they use different words for different meanings, you'll end up with noise. So what we propose is a thing like annotation school, where just like safety school, you would learn the proper words, perhaps a brevity code for annotation, if you will, so that not only do we understand the experience level of who's writing, they're going to write in a common syntax, which is going to increase the usefulness of the data on the backside.
PenFed checking and savings accounts are here for all your adventures. From
Do you take this man to be your husband?
I do.
to
He has your eyes.
He's perfect.
learn more at penfed.org. Federally insured by NCUA.
Okay, so we're not doing this right now, but companies are building AI. They're building autonomy for combat systems. What are they doing to train?
Since the government isn't giving them any data, they're doing what they have to do, and they're going to make up their own. In fact, we've talked to very many AI companies, and the majority are using those same computer-generated forces that we talked about earlier to make up scenarios, run it a bunch of times, and find the best outcome. However, like we said before, there's no tactics involved. There's no human feedback in a loop. If you make a scenario and run it a million times, you're not getting the tactical human feedback. You're getting the best answer. And that best answer might not be explainable or even desirable. It could be something that we don't want to happen or unintentionally breaks a rule of combat that changes daily.
Well, and also I have a question. I mean, how many of these simulators are completely physics-based? So are we training our autonomy to behave and make decisions and do formations and tactics in a scenario that might not be supportable in the physical real world? Is that a potential hazard?
There's not a joint all-domain physics-based simulator in the planet. In fact, it's kind of...
Okay, well, let's narrow it down. We don't need to do a joint all-domain. Let's just talk about the air.
So even in air, there's very many simulations going on at the same time. So there's a simulation for the radar cross-section, both offense and defense, and the speed and altitude and the capabilities of everything. But the key part is, although it's really good for training when we're in the loop and we're flying the simulators and we're doing the tactics, if you just let the computer learn against itself with a CGF that was not designed for tactics and doesn't have tactics, human-based tactics in it, you don't know what you're going to get.
Well, and looking forward, I see problems there because if we aren't integrating the warfighters in the way that you and Drifter have been talking about, how do you continue to modernize and sustain and evolve the autonomy even once we've had it fielded? Let's just say you have a company that's able to field a phenomenal CCA, and that's an early min-viable product, but we're like, hey, that's amazing. But if we don't develop some way to continue to evolve that with the warfighter, especially as the warfighter begins to figure out to do new things and different things with the CCA, we're missing the entire point.
We already see it in early CCA things where there's results that we don't like or that we don't understand, and nobody can explain why. The important point here is what we need to do is step back and say, if we improve our human learning, by definition, we are going to improve the AI learning with our involvement in the future. If we do not, we're going to have to live with the consequences of brittle and opaque results. And we can learn from history here. The civilian AI industry had great algorithms for a long time. We could have had ChatGPT-like stuff decades ago if the data was available to do it. The Joint AI Center, when it was developed and run for a while, made great algorithms, but without any data to train those algorithms, they were brittle, inflexible, opaque. and the whole place stopped. So history will repeat itself until we get a proper data set.
Yeah, Lucky, I agree. And to kind of take one quick step back here, you asked, like, how are companies developing AI if they don't have this contextual data? The answer is you actually can train an AI model without contextualized data. It's just not going to be very good, and you're not going to be able to explain why it did what it did when it was done. Because basically, you hit an asymptote for accuracy. The computer scientists will call it an F1 score, and it's a rough approximation for what accuracy is. And this isn't a perfect analogy to the tactics that Bobaloo was talking about, but it's close. In the computer vision space, there's a great example. There are several like auto ML functions in different cloud computers or cloud computing fabrics that will take all of your data and run it through and give you kind of a generalized model. The problem is it's not very accurate. Like it'll hit maybe about 70% accuracy. And that's cool if you're okay being wrong 30% of the time. But I think we've already established that in a military operation, that is completely unacceptable, as it is unacceptable in self-driving cars, which is why all the self-driving cars went to data annotation companies to get humans in the loop to increase their F1 scores. So you're going to have to do the same thing for reasons we've already stated in the military world. But you need people who understand what right and wrong look like in the fighter pilot context, and there are very few people there. So we've established all that. And then, as an example, at Skydio, we make autonomous systems, and they are awesome. They can do some amazing things. So our autonomy creates an obstacle avoidance capability, so you can't crash the drone. We also can create autonomous behaviors to do some really cool things, like doing autonomous inspections of aircraft, electrical infrastructure, bridges, buildings. And these are highly accurate things that are saving people tons of time and hopefully one day increasing the FMC rate of the fighter community in the Air Force. But those are kind of narrow applications. It is a relatively simple thing to do. By the way, we are doing data context, but I don't need a fighter pilot expert in tactics to identify the edges of an airplane and develop a flight path around it, so that it doesn't hit the airplane and it's in a good position to get the right images. So that, I think, is the major difference.
So it sounds like without the contextualized data, for the kinds of things that we need these algorithms to be able to do, it's garbage in equals garbage out.
Amen. You can't have it both ways. You can't have flexible, explainable, and then therefore trusted warfighter AI with no context. You can have AI, and all of the AI companies that are out there now that say, yes, give us all your money, we will make AI. They are not lying. They can make those algorithms. The problem is, without the specificity of this is what we expect out of the AI, which doesn't exist now other than abstract documents, they're going to make what they can with the limited data that they have. And we're raising our hand right now saying that's not going to be acceptable in the long term.
Okay, so you mentioned explainability and trust. What exactly do you mean by both of those terms, and why does it matter?
If an autonomous system or AI comes up with a solution and we don't like that solution either because it's against a rule or it doesn't go to the outcome we're looking for, i.e. the commander's intent, that's a very part of the context going in. If we don't like that and we're unable to change it on the fly for the next mission or the next day or the next syllabus, then what are we going to do? We're not going to use it. Likewise, if we have a CCA wingman and we go into a mission and it does something that we don't expect or don't like, are we going to use it tomorrow? So I would submit that the word trust shouldn't be used as a technical term, but as a warfighter buy-in term. If the warfighters are involved in the definition of the requirements, they're involved in the data contextualization, and then the use of the output, their trust goes up. And that's the most important trust, whether it's a CCA on the wing of a fighter pilot or the COCOM deciding to use AI or autonomy inside of a mission. that warfighter trust, in my view, is the only trust that matters.
And if you have explainability and something unanticipated or undesirable happens, you can understand why that happened and then resolve those issues. And that increases trust as well.
And it requires contextual data in the training of the algorithm to get it.
Yep, Lucky, agree 100%. The way I think about explainability is basically an explainable system offers insights into how its decisions are made. And another way I think about it is predictability. So based on X inputs, we expect to see Y in outcomes, but then Z actually occurred. And an explainable system is one where the delta between Y and Z is a minimum. Okay. And then when I think about trust, I think that's harder to define, but I think it is accurate to say that if you have an explainable system, then it's going to be something that humans will trust. And then my proxy variable that I look at to assess the trust of a system is proportional to usage. So if people trust something, they're going to use it more. If they don't, they're not going to use it. And I think we've all experienced this throughout our flying careers when we get whatever the new kick-ass feature was in the aircraft software or on the targeting pod, and then you go to try it, it didn't work. So you try it the second time, it didn't work, and you never turn it on again.
I think an important pile on to that, by definition, the advanced autonomy, AI, CCA, Golden Dome kind of stuff that we're talking about is going to be used in probably the most important warfighting things that we do as a military. It's not going to be an easy thing that we just do on the side. This is going to be a major thing. And every major thing that's ever happened is completely different than what we planned for.
Yeah.
By definition.
Yeah.
One of the reasons we want to use advanced autonomy and AI in the future is to be able to adapt to that. But contrast that with no data to train it. We're expecting something that physically cannot happen unless we involve a lot of warfighter context and experience and learning into the system on the input side. Otherwise, it's going to be very brittle, hallucinate on day one, and not be used, and we've wasted all this time building something that we can't use.
All this time and all this money and all this force structure. Okay, so I'm hearing we got to get the warfighter involved. We've got to get the warfighter involved, and I'm 100% in agreement with that. So kudos to the Air Force for standing up the experimental operational unit at Eglin last summer, right? Because they're trying to understand how do we integrate warfighters with CCAs, or how do we integrate CCAs with warfighters? And so it seems to me like that's the right direction for them to fly, learn, and then fly again. So they recognize the importance of getting pilots and operators involved early in the autonomy development. So what are your thoughts there? I mean, it seems to me like this interaction would be key to cultivating that robust industrial base for autonomy. Are they capturing the data? What is that feedback loop looking like?
They're not doing that to the best of our knowledge. We've been working with one of the major CCA vendors for a long time, and therefore have contact with the EOU Bubbas. But they're not gathering any contextual data, and they don't have input to the system. They're just seeing what the output is. And they're even starting to see now that, hey, why didn't that happen? And nobody knows the answer to that. Having said that, our methodology and our approach is agnostic to the application. We've talked to a few key leaders this week in DC, and many of them gravitate to the EOU and the CCA program as a good place to start. But truthfully, it doesn't matter. We could start at the government's behest on any of the important programs, and the methodology would be the same. Involve the warfighter in the development of these requirements, start gathering their data, add it to the collective, let them learn better, and amass that over time.
Yeah, I agree, Lucky. I think the EOU is a step in the right direction. It's one of those necessary steps, but not yet sufficient to completely solve the whole problem. It actually reminds me of something the Army did several years ago, which actually turned out to be a good thing. When they created Futures Command, they looked at the Army priorities. There were 8 of them, and they basically put a senior leader in charge of a team with a senior acquisition official, a senior warfighter, and a senior technologist in that line of effort, and they went and started doing great things. So this looks like a similar model that the Air Force is doing. So I predict good things will happen. But they are going to have to, in line with what Bobaloo was talking about, start thinking about their data strategy, because it seems to me that that is somehow divorced, right? It's almost like the Air Force still has the CIO shop focused on that, and never the two shall meet. It's almost like a brick wall between the two. So if I were going to do anything, I would add some data scientists into some of those groups at the EOU, or as Bobaloo's team calls them, cognitive systems engineers. I think that would be something that would be valuable and the Air Force should consider. But I will also tell you, Lucky, what people need to start doing, because when we talk about EOU, we're talking about requirements, right? And getting requirements out to industry that they need to file or need to follow. I have yet to see in any AI solicitation any mention of the need to comply with DoD Directive 3000.9, which is lethal autonomous weapon systems. And it is absolutely going to be a requirement. If you want something, basically what that publication does is if you have a lethal autonomous weapon system, it describes all the conditions that must be true. And many of the things that we were talking about, explainability and trust, are actually written in that document. And yet no solicitation I've seen come out has actually referenced that. And as I think we all understand, if you don't make something a requirement, it's highly unlikely that you're going to have a prime or even a new non-traditional prime that is going to spend the money and do the effort to do something if it is not required. So I think it's like high time that that starts to become a centralized requirement.
Yeah, and if it's not a requirement and companies don't do it, those things are not going to be built into the foundational software, and it's not going to be a bolt-on. You can't just bolt on trust and explainability and all of those things. You have to develop that and cultivate that and train that over time.
Yeah,
That's exactly right. Now, there is an alternative. The government could execute its own data pipelines, build its own contextualized data, and then supply it as GFE. But there are some challenges with that as well.
So if we capture all this data, we contextualize all this data. I mean, Drifter, one of the things that you mentioned was discoverability. Like, we've got to be able to make the data discoverable. Is that part of the process?
Yes. And to that end, we've been talking with Microsoft, and I think that's the perfect sort of collaboration that needs to happen here. First off, there's going to be a lot of software that needs to be made to give the warfighters the UI to be able to input this data without being obtrusive. That's going to have to be scalable. So a software house that can scale up to do that, guided by cognitive systems engineering and a good go-between between the DevOps engineers and the warfighters, that needs to happen. Once that UI is in place, however, we need a secure cloud infrastructure for that data to be amassed. And so that's why a AWS, Google, Microsoft kind of partner in the deal helps with both sides of that equation. CSE coupled with a grounded methodology to get contextualized data, grounded with a secure cloud infrastructure, is going to be the asymmetric advantage.
So, I mean, let's just say that we get the EOUs, they begin to capture and contextualize the data that then feeds into the autonomy for CCAs. Do you envision this process going to the line units? I mean, I would have to imagine that frontline units would need to continue the data contextualization process to continue to refine the CCA.
Yeah, it's a continuous process that will never end. Warfighting is not a static thing. Certain aspects of warfighting are pretty static across time. Like if I was going to go do BFM with Drifter, the BFM largely remains static. So we could human label and give that context and perhaps teach a machine learning algorithm to label that kind of mission because it doesn't change and get more efficient. But for those instantiations where it's constantly evolving, there's new tactics, there's new toys, you're going to have human in the loop continuously evolving the set and then retraining the AI algorithms as a result. So you never stop. You just start and then you continue to build. And the longer you do that, the more robust the data set gets, the more explainable, trusted, and flexible the outcomes can be.
Yeah, I can throw a couple things in here. So at a high level, what we're really talking about here is a data strategy I do have a couple of inputs that I think would be valuable in a data strategy. And this isn't rocket science. People have talked about this before, but consideration number one is we have to remember that airplanes don't operate alone. Okay, we operate in a joint environment, and that includes maritime assets, space assets, cyber effects. There are going to be EW effects. So while we're capturing contextualized data for the BFM sortie that Bobaloo and I just flew, we also have to realize that we have to, in time series, understand what everyone else is doing and have those experts participate. So I think, again, going back to the acquisition system, as requirements are being written, I do think, and don't want to slow the process down, but there needs to be a joint element in this so that the way the Air Force is doing it at least rhymes with the way the Navy is doing it, so that we can connect the dots on the back end of that system. And then Bobaloo mentioned the infrastructure that would run this data strategy we're talking about, super important. And I think the government over the last 10 years, I know I participated in it when I was at Microsoft, is a little more comfortable with the use of cloud computing capabilities now, and that's going to be important. And I know that the hyperscale cloud providers have invested, I know specifically at Microsoft, we had to invest billions of dollars to create separate infrastructure to do process classified information, all the way up to things we can't talk about on here. So hopefully that comfort level will manifest in this data strategy. But I go back again, we got to bring the cyber folks and the CIO folks along, and they've got to be like walking side by side on this path. Otherwise, it's going to be, well, the CIO is the land of Dr. No again. They just disprove everything. So it's going to have to happen that way.
Yeah, I don't see how they can stay out of this, because moving forward, data, information, all of the infrastructure, the hardware systems, the pipelines, that is all going to be essential to enabling and empowering this AI transformation. So they have got to begin to move forward. Okay, gentlemen, so where do you think we'll be at the 5 and 10 year mark? Pull out your crystal ball and give me where we are with the current trajectory and where you think we should be.
I'm extremely enthused about the reception to this from the key engagements that we've had in the recent past. In fact, one key individual said, okay, this makes so much sense. How come I haven't heard of this before? This is just common sense. And that's the beauty of it. Once you understand that without getting contextual data in the hands of AI companies, we're not going to get what we want. Okay, now what? So I think where we are at with the current administration and the push to move fast in a pragmatic fashion, coupled with the asymmetric advantage that AI could bring in addition to improved human learning, if we adopt requirements in the very near term and start empowering warfighters directly in the requirements process and then thereby getting contextual data into the system, I think in 5 to 10 years, we will actually be using the output. But every program needs instantaneous output to be popular. And that instantaneous output is the increased human learning that will result in the very near term.
Drifter, what do you got?
Yeah, Lucky, I'm going to give you the total weapons school answer here.
It depends.
It depends. I agree with what Bobaloo said. I'm hearing the right rhetoric come out of the mouths of senior leaders, and that's a good thing. I will say, I think we've all experienced this before. Sometimes actions don't always follow from rhetoric. I'm hopeful in this case that the actions do follow the rhetoric. But again, it totally depends on whether the Air Force, the other services, and the senior leaders actually follow through and build these pipelines that we've talked about to add context to data. And if they do that, I really believe we will see autonomous systems in the next 5 to 10 years being not only critical, but instrumental players in our fighting force. They will be real value-added contributors. On the other hand, if we don't do that and invest in it right now, it's really simple. We lose.
That's a footstop moment. Like, drop the mic. We could end right now. But I do want to say, one thing that just occurred to me based off of what Drifter's been saying as I've been thinking about it, is that this process, if the Air Force is able to contextualize their own data, they own the data sets. And right now, a lot of the autonomy companies are developing their own data sets to train their algorithms in a way that the USG doesn't necessarily own that data. They don't have insight into how or why the different autonomy companies are performing and behaving differently. But if the Air Force develops its own contextualized data, it has that entire data pool. And if we're able to integrate that with the other services like the Navy and the Army and so forth across the entire DoD, that then suddenly becomes incredibly powerful to create a vibrant AI industrial base with understandable and explainable and trustable outcomes. So let's wrap up the conversation here. I've got a question for each of you because you've both flown in combat. You've done the JOB. I mean, patches, instructors, top of the game. As you look at autonomy, what one area of employment or task would you apply autonomy to first to gain the most?
Well, being a fighter pilot, that's an easy answer. We've all sat and dreamed about having the perfect wingman that has 17 times the weapons that I can carry by myself and that can just do what I'm thinking in an offensive or defensive way. I think that's a game changer.
That's really complex. Like, that's super hard, right?
And it's not just one domain. Even when we talk to the EOU guys about, perhaps a pilot project doing this for CCA now, no very important mission is single domain or single service anymore. It just cannot be. Although it sounds easy to go, well, let's just do the air first. There is no just air thing anymore. And if you start decomposing, what a CCA would do, even to be able to penetrate into a contested environment and be a missile truck, that is very complex very quickly.
Yeah.
So there is a giant leap between the thing is able to fly on my wing and employ tactically without just getting killed in the first day or doing something we don't understand. But that's how I would use it if it was my check.
Drifter?
Yeah. So, Lucky, I think in general, you have to do some things in parallel. So in the startup world, we take moonshots, but at the same time, we're going after quick wins as well, right, to build momentum. And I see a parallel to how the military adopted cloud computing. So when we started adopting cloud computing, we didn't go straight to our nuclear command and control systems and put everything in the cloud, right? We started with back-end business systems that if it failed and we lost access and all these fears that we had, the Air Force wasn't going to come to a grinding halt and people die. And then we built confidence in that as more and more of those systems went in. And then we started applying it to some of our tactical systems to where you were lucky for a while, Alice running in the cloud, capturing maintenance data for the F-35. Okay, great. So I think we're going to see a similar trajectory as we adopt autonomous systems in the Air Force and in the Joint Force. So I agree with Bobaloo. We need to go for the moonshot right now, which is CCA, Golden Dome, et cetera. But I think we can also start getting some quick wins. And those quick wins don't need to be, a huge aerial vehicle. It could be a small one. And I'm going to throw in a plug for Skydio here. Maybe we start looking at doing more autonomous aircraft inspections, saving maintainer time, increasing FMC rate, using drones, secure bases. We've actually talked a lot about packaging these things up in docks and then being able to remotely operate them at austere airfields. So as we play our agile combat employment game to complicate targeting, we can now reduce the number of security forces folks that you might have to send along with it. So I think those are some ways to build some quick wins that we can do while we are also going for the moonshot.
Drifter, I really like how you laid that out because going for a moonshot, you have to start now. Because it's going to be hard. It's going to be very complex. We've got to manage those expectations, but we have to stay committed despite the challenges. And we can't give up the wins and the learning that we'll achieve with those minimum viable products. Great pathway. Gentlemen.
Yeah, and another thing that, Lucky, you actually start to build trust in the concept of autonomous systems. The more people start to use them, the more the general trust level goes up to where they will invest in, the more advanced stuff. And we see this every day. Like when ChatGPT first came out, no one trusted, no one did anything. But now, ChatGPT can do some very meaningful things to help people in businesses and life, et cetera.
Yeah, no, exactly. Well, gentlemen, thank you so much. Drifter, great to have you back. Bobaloo, we look forward to having you back on the conversation. And so we'll see you next time. Have a great air power kind of day.
Thanks, Lucky.
Thanks, Lucky.
And with that, I'd like to extend a big thank you to our guests for joining in today's conversation. I'd also like to extend a big thank you to you, our listeners, for your continued support and for tuning into today's show. If you like what you heard today, don't forget to hit that like button or follow or subscribe to the Aerospace Advantage. You can also leave a comment to let us know what you think about our show or areas that you would like us to explore further. As always, you can join in on the conversation by following the Mitchell Institute on X, Instagram, Facebook, or LinkedIn, and you can always find us at mitchellaerospacepower.org. Thanks again for joining us, and have a great aerospace power kind of day. See you next time.